Hello, this is Mrs. Taylor, and I'm going to introduce you to general solution and initial condition. So, the general solution of a differential is the antiderivative and the constant of integration. So, for example, it says find the general solution to the exact differential equation. And they're telling you dy over dx equals secant squared x plus 2x plus 5. And basically this is just another way of them telling you to integrate. So I integrate this function and write plus c at the end, and that would be known as the general solution. So if I integrate secant squared x, it's tangent x. If I integrate 2x, it's x squared. Integrate 5, it's 5x, and then I put plus c. And then on the left side here of the equal sign, if I integrate dy over dx, I'm just left with y. So that would be known as the general solution. This is a set of practice problems. I am giving you practice with trig and exponentials. And remember if you integrate 1 over x, it's natural log. So you need to practice these types of integrals because they're a little less obvious, a little harder to remember. So work on this for class tomorrow.
Calculus.
So keep in mind that the solution we found was not unique. In other words, that c represents any possible constant. So in order to find a unique solution, we have to be given what they call an initial condition. And this is information that allows us to find what they call a particular solution. So remember, we just found the general solution, but if they ask me to find the particular solution, I have to have the initial condition. This means we solve for c after we find the general solution and come up with a unique solution. So in this example, it says find the particular solution to the equation dy over dx equals e to the x minus 6x squared, whose graph passes through the point 1, 0. So first I will integrate dy over dx to get the general solution, and then I will solve for c to find the particular solution. My general solution is y equals e to the x minus 2x cubed plus c. And then I take the point 1, 0, plugging in 1 for x and 0 in for y, and then solve for c. If I start by substituting 1 in for x and 0 in for y, I get 0 equals e to the first minus 2 times 1 cubed plus c. So then I will subtract e and add, this would simplify to 2. So c would equal negative e plus 2. And then for the final answer, which would be the particular solution, I would just take that c value and substitute it in here. Therefore, my particular solution would be y equals e to the x minus 2x cubed minus c plus 2. And that is the difference between a general and a particular solution. General has the plus c. Particular uses the initial condition to solve for c. So this is a set of problems to practice finding the particular solution, and these again involve some trig, some exponentials, some negative exponents to kind of just get you in the habit of practicing integrating those types of functions. So please work through these for class tomorrow as well.